All right, so your homework on page 586. Number 9 says, Jupiter's moon, Io, orbits Jupiter once every 1.769 days. So that's the period of Io. Okay? 1.769 days. And you have to change it into seconds. So you're going to multiply it by 24 hours per day. And then you're going to multiply it by 3,600 seconds per hour. Okay, and so I/O really becomes 152,841.6 seconds, I believe. Okay, and it has an average orbital radius of, so it's giving us R of I/O as well, of 4.216 times 10 to the 8th meters. And it wants Jupiter's mass. So you have the period and the radius of orbit of something that's orbiting Jupiter, and you're looking for the mass of Jupiter. So remember our equations from last night's video is one is r cubed over t squared is equal to a constant, not helpful. One is r1 cubed over t1 squared is equal to r2 cubed over t2 squared. Not helpful in this case. One is v squared is equal to g, mass of the central body, over r. Okay, not helpful. And then the last one is r cubed over t squared is equal to g, mass of the central body, over 4 pi squared. Helpful. We have the r, we have the t, we know g, we want pi. We want mass, we know pi and 4. Okay, so this is Newton's version of Kepler's third law. And it's probably the one that you'll use the most, at least in the beginning. So I'm just going to switch sides with it. So g, mass of the central body, over 4 pi squared is equal to r cubed of I/O over t squared of I/O. And this central body is really Jupiter, so you could put a j there if you want. So you're solving for Jupiter, take the 4 pi squared up, take the g down. So the mass of Jupiter will equal 4 pi squared r cubed over g times the period squared. So mass of Jupiter equals 4 pi squared times 4.216 to the 8th, 10 to the 8th cubed over g was 6.673 to the negative 11 Newton meter squared per kilogram squared. And then the period we just found up there to be 152,841.6 seconds. And you have to square it. The hardest part of this is getting it in your calculator correctly. So you have to use that EXP. R is cubed, T is squared, pi is squared. Try not to screw it up too much. And when you do type it in correctly, you should get 1.899 times 10 to the 27th, I believe. Oh, I might be off just a little bit. It looks like I didn't put my 3 in. Kilograms. So these digits are probably a little bit wrong because it looks like I lost my 3. Okay, and I don't want to waste video time trying to find it, but you'll be somewhere close to that. Okay? That was number 14. Or no, that was number 9. Number 10. Charon, the only known moon of the planet Pluto, is an orbital period. So again, it's giving us T, this time of the moon around Pluto. And it's 6.387 days. So again, you're going to need to multiply it by 24 hours per day and by 3,600 seconds per hour. And when you do, you should get 551,836.6 1.8 seconds. Okay, and so then it says it has an average distance from Pluto, so it's giving us our R of 1.964 times 10 to the 7th meters. And it's asking us for the mass of Pluto. And so for those of you that it used to say to me back in grade 11 and again this year, how do we know the masses? Exactly this way. We can watch the satellites, and we can figure out the mass of the central body. So again, it's going to be Newton's version of Kepler's third law. So G, this time it's the mass of Pluto over 4 pi squared is equal to R cubed of Sharon over T squared. Okay, again, rearrange mass of Pluto. I'm writing it out so you don't think it's a planet, although I guess it is a planet. 4 pi squared R cubed over G times T squared. So 4 pi squared, R was 1.964 times 10 to the 7th, again cubed, over 6.673 to the negative 11 kilogram, oops, let's do this right, Newton meter squared per kilogram squared, and this is 551,836.8 seconds, and that gets squared. So mass of Pluto equals, I'm going to do it this time because I know, 4 times pi squared times 1.964 to the 7th, and that's cubed, divided by bracket 6.673 to the negative 11. 6.673 to the negative 11. I didn't type in. Oh, maybe I did and I just couldn't see it. Times 551,836.8 squared. And you should get 1.472. So my answers maybe are 1.472 times 10 to the 22 kilograms. So maybe my top answer was okay then. Okay, so that's number 10. Number 11. I might have enough room. Says some weather stations orbit Earth every 90 minutes. So it's telling us the period is 90 minutes, which of course you need to change to seconds by multiplying by 60. And so you should get 5,400 seconds. How far above the Earth's surface is their orbit? Hint, remember that the center of the orbit is the center of the Earth. So if you think about it, here's the Earth, here's the weather station. We will find the radius of orbit, but then it only wants the height. So you'll need to subtract the R of the Earth. But the first step is to find what's the radius of this orbit. So again, you're going to use Newton's version of Kepler's third law. G m of the Earth over 4 pi squared equals R cubed over T squared. This time, though, you're solving for R cubed. So multiply both sides by T squared. So R cubed will equal G mass of the Earth T squared over 4 pi squared. We know the mass of the Earth. We have a chart that we can look it up. Okay, so it'll be 6.673 to the negative 11 Newton meters squared per kilogram squared. Mass of the Earth, 5.98 times 10 to the 24th kilograms. And then T, 5,400 seconds squared over 4 pi squared. Okay, and what you're going to get is going to be R cubed. So remember, you're going to need to take the cube root of that. So it's going to be 2.946 times 10 to the 20th meters cubed. And so then taking the cube root, 6.6